In this video, we're going to look at the equilibrium constant when we're dealing with pressures. And to do this, we have to go back and understand how pressure in a gas really means concentration. And that is due to the equation PV equals nRT. Pressure times volume equals number of moles times the gas constant and temperature. And so you have moles and you have volume, which is a concentration. Now, for gases, the way we measure something is through pressure. So that's how we relate concentration, is through pressure. And so if we have our Mach equation, again, A plus B goes to C plus D, and it's reversible, we know that the equilibrium equation for liquids is C times D divided by A times B, all concentrations, and all raised to their stoichiometric coefficient. For gases, we use a Kp for pressure, which is just the pressure of the gases, partial pressures of the gases raised to their stoichiometric coefficient. Now, some things about Kp. When we're doing Kp, we always use atmospheres as our units. And Kp and Kc won't always be the same value because of this relationship. Kp is equal to your Kc multiplied by RT raised to the power of this delta n. Delta, every time you see delta, means difference, and n is moles. So this delta n is the difference number of different moles between your reactants and your moles of products. So if your reactants and your products have the same number of moles, and it's then delta n is 0. And so 0 raised to the power of RT, well, anything raised to the power of 0 is 1. So as long as the number of moles of both reactants and products are the same, that's when you get Kp equals Kc. If they're not the same, you have to use this relationship. Now let's see how we can turn this Kc into a Kp. So we have this equation, A plus B goes to C plus D. We know how to get the Kc. Now, using PV equals nRT, we see that concentration equals moles divided by volume. That is what concentration is. Well, pressure times volume equals N times R times T. So pressure equals Na divided by V. That's our concentration times RT equals concentration RT. If we want to get concentration alone, we just divide each side by RT, and we see concentration of a gas equals pressure divided by RT. Now, if we would put all these into our Kc equation, what we would see is that all the RTs would actually cancel out, and so we get Kp equals pressure of your products divided by the pressure of your reactants. And that's it for this video. I'll see you in the next video.